Hi, welcome. I'm Corey Kell. Today we're going to talk about Antarctica and the lay of the land. Specifically talking more about once we understand the lay of the land with regards to each model, the flat earth model and the globe model, we'll get an idea of how we can use Antarctica to identify whether we're on a globe or a sphere or a flat earth model. How I think they kind of figured it out back in 1947. We're talking about the Admiral Byrd expeditions. He did several down in the southern region of Antarctica. The agenda: how much is land and how much is ice and snow down on Antarctica. We'll talk a little bit more about that, show you some images. That shows high mountain ranges up to 14,000 feet. Antarctica has been kind of defined as kind of a big plateau. The ice wall that's said to kind of permeate around Antarctica and in many of the areas, went up over 300 feet. And then some folks talk about the 24-hour Antarctica sun. Really not the answer. Understanding the lay of the land is. That 24-hour sun is suspect. In Antarctica, circumnavigation not required. We don't need to do circumnavigation of Antarctica if we understand the lay of the land. Do we know how much is land under the ice and snow? Well, we can kind of get a pretty good idea. And again, images. There's been one of the greatest American explorers of all time, Admiral Byrd, spent a lot of time down in Antarctica, decades exploring it, the polar and the Antarctic regions. One of America's greatest explorers. And here we show some images. We can see some of the mountain ranges, some of the terrain that protrudes up out of the snow and the ice. And of course, we have some wildlife, the penguins, and abundance of aquatic water life as well down there in the southern region of Antarctica. And you notice some areas we have water right up next to the land, and then we have ice protruding out from the land masses. So that presents challenges for navigation down there. Some images of Antarctica a little bit higher up. We can see here what looks to be the peninsula of Antarctica, which protrudes out towards Chile and Argentina, one of the major continent, the southern continent, South America. The very tip there showing. Does this give us an indication whether this is whether we're reviewing this from whether it's a globe or a flat Earth model? No, just some coastline images. The ice wall, as I said, about 300 feet, represents another major challenge to navigation down there. It's kind of a barrier. So you can see it's like having a security fence around that continent. There are some areas which don't have the ice wall, but many of the areas do have the ice wall. And you kind of give it a scale the size of this ice wall, how high it is with regards to looking at that ship, and what the scale and the size of that ice wall is. Very, very tall. Images, more images of Antarctica from said to be satellites in space. These are kind of suspect, and this is what you find on the internet. They say they're real images. They look more like CGI, and here we're showing the image of Antarctica on the bottom versus the two up on the top left and right, where it looks Antarctica looks thawed out. And I've never known that continent to be completely thawed out. But again, they're suspect. And again, are we to believe these images? Well, I'll leave that up to the viewer, whether or not you believe what you're seeing is real. However, to me and many others, these satellite images are suspect. But again, just to give you an idea what's out there, what images we're showing. Understanding the lay of the land with regards to the models, the FE model and the globe model. A little bit more. We need to understand the directional difference in the models, and the best way to do that is using a circle. And we use a circle to explain the continent itself. The entire continent itself is kind of like a circle. For the globe model, it's said to be at the bottom, or the southern bottom of that model. And the globe model up on right. And you note that the arrows, or the arrow that curves around that, so that globe model is kind of like the exterior. That landmass would hook in towards the land itself. And again, this is shown by this area up on the top here. And what we're looking at You can see that this arrow, it hooks in. If this is the landmass, that coastline is going to hook in towards the landmass. So that's and then on the bottom we have the flat Earth model. You can see here it's just the opposite. So on the FE model, that landmass would hook out, or the ice would hook out towards the water. So if this is our landmass, this would be the coastline that will hook back out towards the water. So just the opposite effect. So it's kind of like day and night between the models, and that's understanding the lay of the land. And circumnavigation not required. We don't need to completely circumnavigate Antarctica to understand that. However, dead reckoning navigation is required in the southern area. The compass is said to have difficulty working down in the south. But understanding those directional differences with regards to landmass, understanding that is. Antarctica, figuring out what I think they figured out in Antarctica, and I'm talking about Richard Byrd and the government. When they went down there and they did some exploration, we have the globe model on the left and the Gleason's flat Earth model on the right. The size of the Antarctic continent for the globe model, about 11,000 miles. Antarctica, right around 59,000 miles. If we do the breakdown, this is the breakdown for each model. 33 1/3 degrees by 10.8 gives us a circumference of 360 degrees, 15 by 24 for the FE model. And again, we can break that down into sectors, 24 sectors, roughly about 2,400 miles. 11 by 10.8 giving us right just over 1,000 miles. So a 2-to-1 ratio, but a 1-to-6 ratio in total area mass. Dead reckoning, how dead reckoning works, and we're using a cross, or you can use a watch. By simply paralleling the coastline, if we're going straight, you can see on the globe model that what we talked about before, that coastline is going to hook in or continue to hook in. This on average of 33 degrees. Now, does that include those bays? You're going to have geographic terrain features like bays and inlets. No, we're talking about the larger landmass in itself. On the Antarctic coastline for the FE model, just the opposite. That coastline is going to hook out at about 15 degrees over a greater area or greater expanse. Understanding dead reckoning and how that works will give us the answer to that. Now, can we do that with a ship or an aircraft? Aircraft is the best way, and that's how I think they figured it out, using aircraft when they got enough assets down in the south during high jump. They kind of figured that out. Byrd was an exceptional navigator. Here we have the Gleason's flat Earth map, and we'll talk a little bit more about dead reckoning. The T representing the plane, and we can see that this model, as I said, the coastline Antarctica goes all around the circumference of the known world. Here we have Argentina and Chile here, the very southern. If we were to fly down, running into Antarctica at the 12 o'clock position, the coastline running at 3 and 9 o'clock position going out. Can we tell if it's the globe or a flat Earth model just by doing that right there? No, but it gives us an idea. You can see how the coastline, what I talked about before, hooks out or it curls out. So that's going to be one of the major differences, understanding directional difference. Again, part of the answer how I think they figured it out. Again, you have to understand navigation. This is the azimuthal equidistance map. Again, we see the Antarctic Peninsula here and here. We have a plane that is paralleling or using dead reckoning as it goes along. And of course, we talk about you have these little geographic inlets. You're going to see those, but real experienced navigators are going to kind of understand that. And that plane paralleling that coastline being at the if his plane is at forward motion is at 12 o'clock. His coastline going in that direction, which would be westerly, the landmass would be off to his left or at the 9 o'clock position. Same thing for the globe model. Here we see the globe model. We have the continent of Antarctica coming straight down. Can we tell if it's a globe or a sphere or a flat Earth? No, just coming down. We need to do more dead reckoning on that coastline. And here you can see the big difference. So when I talk about that coastline, it hooks in or hooks around. So do I need to go completely around that continent for circumnavigation? No. I don't need to do that, but I do need to know how to do dead reckoning navigation, and that will be a big answer. That will tell me as to whether or not I'm viewing this continent on a flat model or a spherical model. And again, now we have to understand there are geographic features such as inlets and bays. Knowledge of navigation, being an expert navigator, you're going to need to understand that, what you're looking at, what you're actually seeing as you navigate. The Byrd, as I said, the Byrd expeditions, how I think they figured out in 1947, an operation, they did operations after that, they did high jump and several expeditions after that. And they really got a lot of assets down in the south and eventually built the base down there. So circumnavigation, no, it's not required to identify whether you're on a flat or a globe model or a sphere model. Again, talking a little bit more about understanding how that land would graduate out for an FE model. That coastline hooks out away from the landmass. If this is the landmass, this is the ocean. That landmass is going to hook out back towards the ocean, so it graduates back out towards the ocean at long distance. And this is how I think they figured it out. As you can see, that those planes would have used the coastline to navigate using dead reckoning because the compass doesn't work down in the south, or it's very difficult. On the globe model, just the opposite effect. You know, you're going to get that opposite effect. The Antarctic coastline would graduate back in, so it's just the opposite. Now, additionally, what I think they did is they probably put transponders along the coastline that kind of help map that out along the coastline as well. Again, getting more assets down there, they kind of figured that out. And we can see here for the globe model, again using dead reckoning, if we're traveling along the coastline, again our forward position at the 12. Now here on the left side is probably not the best example, but again later on it graduates in the continent. Of course we're going to have some ice and stuff outside the actual landmass, but here on the position 3 and 4 we can see that almost goes at a right angle, so you would have to do a hard turn in for the globe model. And that's really where you'll be able to identify if you're on a sphere versus if you're on a flat model. And that's a huge difference. Understanding that is the real answer. I'm Corey Kell, creator of the FlatEarthIntel.com, and this is today's presentation has been about Antarctica and understanding the lay of the land. Thanks for watching.